Marathwada University Nanded. Is deliver the lecture on topics of today's lecture, group theory. So, and chairperson of today's session, Dr. Varsha Borgaonkar ma'am, head departments of mathematics, NES Science College, Nanded. I request to Borgaonkar madam to chair this session. I am handing the charge to Dr. Borgaonkar madam. Please, I request Dr. Borgaonkar madam, please give me a chance.
Thank you, sir. Good evening, everyone. First of all, I'm thankful to Dr. Chavan sir for giving me the opportunity to chair this lecture. I would like to welcome all the participants and our eminent speaker of the second day lecture of this lecture series of this 1 week national level lecture series organized by Department of Mathematics, Digambarrao Bindu, Arts, Commerce and Science College, Bokar. I take this opportunity to introduce our today's eminent speaker, Dr. N.S. Darkunde. He is working as an assistant professor in mathematics, School of Mathematical Sciences, SRTM University, Nanded. He has 12 years of experience, teaching experience. His area of specialization is group theory, Galois theory, representation theory, coding theory, functional analysis, etc. He has published 8 research papers in different national international journals. He has completed 3 major research projects and 2 minor research projects. Also, he is working for 1 minor research project. He has delivered many invited talks, more than 50 invited talks in different and guest lectures in different conferences and workshops. He is working as convener and member of different committees of Swami Ramanand Tirth Marathwada University, like Swayam and MOOC courses center, anti-ragging committee, etc. He has received Best Student Award during the final year of his BSc. Also, he has received the Best Paper Presentation Award in different conferences. Also, he has received Best Paper Award in the different conferences. He was honored with Top Performing Mentor Award 2018 and 2019 from NPTEL IIT Madras. Also, he has received NPTEL Motivated Learner Award and NPTEL Discipline Star Award and active SPOC recognition from NPTEL IIT Madras. With this short introduction of Dr. N.S. Darkunde, may I request Dr. N.S. Darkunde to start his today's lecture on the topic group theory. Thank you.
Thank you, Borgaonkar madam. It's my privilege to talk with the participants in this national workshop. So I also convey my thanks to Dr. S.B. Chavan sir, as well as the principal of Digambarrao Bindu College. So the title of my today's topic is group theory. So we are going to just introduce group theory from the scratch. We are going to introduce the groups via scratch. So it will be rudimentary introduction. So it will be a interactive session. I request all students to have a active participation in this. I will be delivering a very elementary talk. Okay. So first of all, let me just show you something. Wait for a moment and. So most of you are BSc students. So what we are going to do, we are going to see how groups have been originated and what is the motivation behind that. Okay. So let me just share the screen. Share the screen. Where the screen is visible? Is screen visible?
Yes, sir. Yes, sir.
Okay. Yes, sir. Okay. Yeah. So fine. So let me just. Wait for a moment. Yeah. So we are going to do one experiment. Okay. So what is that experiment? Experiment is something like this. So this is, I have taken one rectangle, and suppose these are the four sides, 1, 2, 3, and 4. Are you able to see it properly? Yes.
No, sir. No, sir.
You are not able to see it now. Yeah.
Yes.
So we have taken a rectangle, and what we are doing, we are going to play with this rectangle, and from this rectangle only we are going to create a group. Okay. Yeah. So what is happening? So see, I'm going to talk about symmetry. So what is the meaning of symmetry? The symmetry of this rectangle is not just do the movement of this rectangle and bring it to this horizontal side. So what is this horizontal side means? What? Or maybe I can do some sort of I will just say yeah, okay. I will start video. I will just do a demonstration so that you people able to understand. Yeah. So everybody is able to see this. What is there in my hand? Yes. Are able to see the piece of paper? Someone said, is it visible properly?
Yeah, sir. Yeah.
Yeah.
Yes, sir.
So these are the four corners: 1, 2, 3, and 4. This F stands for front side of the paper. Okay. F stands for front side of the paper. And at the back also I written, see this. You can just see 1, 2, 3, and 4. Am I right?
Yeah.
Yes. Are able to see? This is the front side and this is the back side. So what is the meaning of symmetry? Let's see now. Yeah. So if I do the rotation like this, let's say rotation like this is not a symmetry. What is the meaning of symmetry? Symmetry म्हणजे काय बघा, या rectangle ला पुन्हा क्षितिज समांतर म्हणजे parallel to this whatever floor I'm standing on, bringing it to that position. So this. So if I do it like this, will it be a symmetry? It will not be a symmetry because this is not the original position. Yeah. But see, this is a rotation by 90 degrees. This is not a symmetry. But if I do it like this, this is a symmetry. Why it is symmetry? This side is parallel to the floor. This side is also parallel to the floor. That is the meaning of symmetry by me. Okay. Are you able to understand what I'm saying? Yes. So I hope so. Now see, is this a symmetry? So you can just raise the hand. You can just raise. So is this a so this is the x-axis for me, and this is a y-axis for me. Are you getting? If this is x-axis, I will just do a reflection, or I will just flip around the x-axis. मी काय करतो बघा, याला समजा हा x अक्ष आहे आणि हा y अक्ष आहे. तर x axisच्या भोवताली मी याला रोटेट करतो बघा, फ्लिप करतो बघा, फ्लिप. So this is again a symmetry. Are you able to see? This is a symmetry. Okay. So now this is a y-axis. If I rotate it along it, see, you can just see like this. This is also a symmetry. Am I right? Yes. Someone, sir. You may unmute the audience so that they can interact, because if they are able to understand this experiment, then and then the idea of this group will become clear. Okay. So this is the meaning of symmetry. म्हणजे काय बघा, याला पुन्हा मी x y axis च्या द्वारे फिरवलं तर पुन्हा मला ही पोझिशन मिळते बघा. I am getting like this. If I do it along x axis, I am getting it something like this. But if I rotate it like this is not a symmetry. Why? Because the bigger side of the rectangle is not parallel to the floor. Okay. So flipping around x-axis is a symmetry. Flipping around y-axis is also a symmetry. But rotation by, let's say, 90 degree, it is not a symmetry. If I am to bring it to again a symmetric position, so rotate it by 90 degree, again rotate it by 90 degree, so you will get it like this. So this is a symmetry. Okay. So with this, we are going to play today. So let's see what we are going to do. For that purpose only, I have drawn this rectangle over here. Okay. So what I'm saying, if I rotate along x-axis, so what is going to happen? Tell me. So this is the x-axis for me. This is the x-axis for me. So what is going to happen? Tell me. Yes. Anybody? It is going to remain as like this. I'm not worrying about what is happening to 1, 2, 3, 4. If I'm doing about fy means what? Flip around y-axis. Yeah. Again, I'm going to get the shape like this. Okay. If I rotate it by pi by 2, I will get something like this. This is not a symmetry for me. Okay. But if I rotate it by, let's say, r pi, if I rotate it by r pi, again I'm going to get it like this. Okay. Yeah. Also, if I rotate it by 0 degree, if I rotate it by 0, so r0 stands for rotation by 0 degree. If I rotate by 0 degree, that means if I don't do anything, again, I will get that rectangle to be like this. So all of these things are symmetrical. But this thing, whatever this vertical kind of rectangle, it is not a symmetrical in nature as far as original object is concerned. So which kind of 4 objects I have got? I have got 4 objects. So first object is 1. 1 means doing nothing. 1 means what? Doing nothing. Or I will just say rotation by 0 degree. Then fx means flipping around x-axis. Fy means flipping around y-axis. And r pi means what? Rotation by pi. Rotation by pi. So all of this, you can just see that this r0 means rotation by 0 degree. That means I'm calling it as 1. The next symmetry is flipping around x-axis. X अक्षाभोवती त्याला flip करणे. Then flipping around y-axis is again a symmetry. Flipping by or rotation by pi by 2 will give me the object like this. So this will not be a symmetric kind of thing. So I need to rotate again it by pi by 2. That means r pi will be a symmetry. So what I did, I just listed it down 4 objects. Again, I will list those objects over here. See, 1, fx, fy, and r pi. So via this experiment, what we are going to do, we are going to construct one group out of this. We are going to construct one group out of this. So see, what is the operation here? Actually, operation is what? Composition. So I will come to this. I will come to this. Before that, let me just let you know what is the meaning of binary operation. Yeah, what is the meaning of binary operation? I will come back to that experiment once again. Binary operation. So what is the meaning of binary operation? See, I will just take one non-empty set, let's say G. Then if I take a function from G cross G to G, then such kind of function is called as a binary operation. So why the word bi is there? Bi is because of this 2. There are two fellows we are taking. Because of this only, we are calling this as a binary operation. Okay. So in general, most of the times people you should not did by star from G cross G to G. This is called as a binary operation. So what is the meaning of this? No matter which order pair. Suppose I have taken G. So G is from here and H is from here. If I apply star on it, so the resultant should land up in G. It means in this G. That is the meaning of a binary operation. So now question may come your mind. What is the meaning of, or let me just see some example. For example, if I take my G to be equal to Z, and if I take star to be equal to plus, yeah. So in simple words, if I take 2 integers, what about the addition? जर मी 2 पूर्णांक संख्या घेतल्या आणि त्यांची जर बेरीज केली तर पुन्हा पूर्णांक संख्या येते का? So it's true. Why? So because we know that if I add any two let's say integers, then addition is defined to be like this, and m plus n used to be land up in Z. Yeah, this is the first kind of binary operation that we have seen. The second is, suppose I take G is equal to set of natural numbers and I will take star to be equal to minus. So what I need to check whether subtraction of any two natural numbers is a natural number or not. But this is not true. Why? For example, you can take 2 and 3. If you take this 2, 3 from n cross n, then you can just see that 2 minus 3 is minus 1, and minus 1 is not a natural number. Am I right? So we don't want to deal with such kind of binary, such kind of operation. This is not a binary operation. But whatever star equal to plus I have taken, this is a binary operation. Okay. So with this, I'm in a position to define what I mean by group. What I mean by group. So what is this group? A group G is a non-empty set. A group is a non-empty set along with star as a binary operation. Star may be anything. Star as a binary operation satisfying following properties. Satisfying following properties. Satisfying following properties. So what are those properties? Let me just list it down. The first property is associativity. First property, or some people say closed under binary operation, but already I have taken this star to be a binary operation. Therefore, I don't need to mention what is that binary operation. Okay. So what is the first property? First property like this: A star B star C is same as A star B star C, which is true for all A, B, C belong to G. What is the meaning of this? It says that no matter where you put parenthesis, म्हणजे तुम्ही ब्रॅकेट ह्या B आणि C, B च्या डावीकडे आणि C च्या उजवीकडे ठेवा किंवा A च्या आधी आणि B च्या नंतर ठेवा, उत्तर सेम येणार. That is the meaning of associativity. So next thing is existence of identity. Existence of what? Identity. So what is the meaning of this? The identity is like this. So what it says, there exists E belong to G such that A star E is equal to E star A is equal to A for all A belong to G. Mathematically as like neutral. So some people also call this E to be as a neutral element. So there is a neutral element, let's say E, such that whenever we take its binary so when we take this operation star with any member of a group G, we should get that member back once again. That is the meaning of existence of identity. And the next thing is what? Existence of inverse. Next thing is what? Existence of inverse. So what is the meaning of this? What is the meaning of this? It says that for A in G, there exists A inverse in G such that A star A inverse is equal to A inverse star A is equal to identity. And this thing should happen for each and every element from group G. Okay, so I'm saying that, so no matter which A you take from G, they always take this one element A inverse in G such that A star A inverse is equal to A inverse star A is equal to A. So any object, let's say G, any object G along with star and which satisfy these properties is called as group. Such order pair is called as group. Okay, so now question may come in your mind, if this is a group, then why we have taken this example first? So I have taken some sort of, let's say, experiment over here. So some students are annotating here, so let me just remove them. Okay, fine. Okay, so I have taken this experiment of doing the flipping. So what I'm doing, I'm going to compose them. So now see, composition of 1, that means what? Doing nothing. It means neutral element. So it will come out to be 1, it will come out to be fx, it will come out to be fy, and it will come out to be rπ. Now let's see what is next. Fx compose fx, that means what? Flipping around the x-axis twice. So how will I achieve this? Let's see. I will again do that experiment. Okay, so I want to do now what? Fx compose fx. So how will I do it? Let's see. I will do it like this. So see, how will I flip it around x-axis? Flipping around x-axis means what? X-axis high x-axis hai baga. So I will do it like this. Okay, I will do it like this. And again, fx compose fx. So again, I want to rotate around x-axis, or I want to flip around x-axis. So I will get it like this. So I'm getting my original paper back. So you can just see 1. So here is 1, 2, 3, and 4. So f means front. So I started with this. Okay, flip around once. If I flipped around once, I'm getting like this. Then flip around once again x-axis, I'm getting it like this. So what I'm getting, if I flip twice around x-axis, I'm getting my object once again back. Okay, the next thing is, now let's see. Let me just flip it around y-axis. Yeah, this is my y-axis. If I flip it like so, look at my original object. F is in front. Yeah, F means front. This B means back. If I flip it around y-axis, this is the y-axis. So I'll get it like this. I'm not getting the original object again. But if I flip it again around y-axis, I'm getting it like this. Are you getting? So what I'm getting, fy compose fy is again identity. Fx compose fx is also again identity. Okay. So let me just go back to my this slide. Okay. So what is happening here? So fx compose 1 is 1. But if I take this fx and again this fx, this is fx. So this should be 1. Now I am eager to see what is fx compose fy. I'm eager to see what is fx compose fy. So for this purpose, what I'm going to do now, see what I mean by fx, flipping around x-axis. See, I'll flip it around x-axis. I hope you are able to see. So I'm flipping. Now what I want to do, I want to do fy. Fy means what? Flipping around y-axis. So this is my y-axis. I will flip it like this. So look at this, what I'm getting. I'm getting that f is inverted. Now I'm eager to see what is this object. I'm eager to see what is this object. So keep it in mind. Keep in mind this picture at the back of your mind. So see, what will I do? So I remember what I got it like this. So I want to achieve it via this. Now let's see. What will I do? I will rotate it via what? Pi. Yeah. If I rotate it via pi, so I know that this is not a symmetry. This is not a symmetry. But if I do it again like this, so I'm getting like this. Are you getting? This is the symmetric object. So what I'm getting, fx compose fy, fx compose fy is coming out to be what? R pi. So this is what? This is what? This is R pi. This is R pi. And similarly, you can just show that fx compose r pi is nothing but fy. So in this way, what we are doing, see, there are four kind of symmetries. So this fx is symmetry, fy was symmetry, r0 means 1 is also symmetry, r pi was also symmetry. So somehow we are preparing one sort of group which objects are 1, fx, fy, and r pi. Okay, so you can just see that we have just prepared a table. Now let me just go to fy. Fy compose 1. That means we need to take this fy and this one. Fy compose 1 means fy. Okay. Fy compose fx means what? Just we have seen it is r pi. Then fy compose fy is 1. Then fy compose r pi. You can check it at home. It is coming out to be fx. Okay. The next is r pi compose with 1. It will be r pi. R pi compose with fx will be fy. R pi compose with fy will be fx, and r pi compose with r pi will be equal to 1. And you can just observe that. See, what we are doing, compose means something like this. See, fx compose fy. So this compose with actually a star that I talked. Okay, so you can just see that all the objects inside this table are coming from the G only. So what it says, the meaning of this means what? My group G is, or this object or this set is closed under this composition. Okay, similarly we can check the remaining properties. So this was some sort of notation. That is the meaning of group. Okay, so this is the meaning of group that we have seen right now. Okay, so we will again go back to that example, don't worry. Okay, so before going that, let me just see some another examples of group. So let me just see one important class of group. So I can take G to be equal to R, and I can take star is equal to plus. You can just check that if I take my G to be set of real numbers and star is addition, then you can check that this R used to form a group. So R plus is a group. So what is the identity? Who is playing the role of identity? 0 is playing the role of identity. If I take any element, let's say A in R, then what is the additive inverse? I will just say that it is A inverse in R, but A inverse means actually minus A, such that A plus minus A is equal to 0. Yeah, but if you do a little bit change in this, let's say, suppose I will just say G equal to R star. What I mean by R star means just remove 0 from R. If I take star to be equal to plus, then we are quite unfortunate. Why unfortunate? Because this R star will not going to form a group with respect to addition. What is the problem? The problem is, what is the problem? 0 is not there in R star. Okay, I hope you understood what I'm saying. Okay, so this is the next thing. The next thing is one important kind of thing is this one. So what will I take? I will take G to be equal to 1 minus 1 I minus I, and I will take my star as multiplication or usual multiplication of, let's say, complex numbers. So what will I do? So operation as I square is equal to minus 1. Okay, such kind of operation is there. So you can just check that this group is closed under multiplication. Am I right? Or this set is closed under multiplication. Why? Because if you multiply 1 to I will get I. Minus 1 into I is minus I. Then again, if you want to multiply this 2, what will I do? You will do like this: I into minus I. Bring that minus outside. So this will be I square. So this is minus 1. Then I square is again minus 1. I'm getting 1, and 1 is going to land up in this G. Okay. So this group is, this is also so this G is closed under multiplication. Then of course you can check that the multiplication operation is associative. Then the next thing is to find out existence of identity. So what is the identity? You can just check that E equal to 1 is the identity. Why this is so? Because you can just check that I into 1 is I, minus 1 into 1 is again minus I, and so on and so on. Okay. The next thing is to find out. So generally, if your G element G is there, then G inverse means inverse of G. Okay, inverse of G. This is the notation that we are going to follow. So with this notation, you can just see that inverse of 1 is 1 itself. Inverse of minus 1 is equal to 1. Why this is so? You can just check that minus 1 into minus 1 is equal to 1. Okay, inverse of minus 1 is again itself. Okay, then you can just check that if I want to have an inverse of I, it will be minus I. Why this is so? You can just check that I into minus I, just we have did it over here. I into minus I is equal to 1. Am I right? And similarly, if I take minus I, its inverse is equal to what? I again. So this is also one useful kind of group that we are going to see, or we have seen just right now. So this is, so we have, as far as this today's lecture is concerned, we have seen these three examples of group. So the next is Q8. Q8 is called as group of quaternions. It is called as group of quaternions. So what are these quaternions? Quaternions are nothing but it is elements are like 1 minus 1, I minus I, j minus j, and k minus k. Yeah, and k minus k. So what is this? There are 8 number of elements. You can just check. Okay. So what are the operations here? See, they are defined the operation like this: I into j is equal to k, j into k equal to I. Okay, and k, so you can just remember it like this. Yeah, so this is I, then this is j, this is k. If you take I into j, you are getting k. That's why I written the first one. Then j into k, it will be the next object, that will be I. The next k into I, it will be j. So this is something like this. But if you do it like this, j into I, it will be minus k, k into j will be equal to minus I into k equal to minus j. And of course, the next operations are I square equal to j square equal to k square equal to minus 1. You can also check that this set Q8 used to form a group with respect to the operation that are just listed over here. Okay, and it's very easy to find out the existence of identity, existence of inverse, and so on and so on. Yeah, so I will just after lecture is over, I will share this copy of this page with Chavan sir. He will share with the students. The one exercise for today is just what? Just find I will just say exercise. Find what is fx inverse, find fy inverse, find rpy inverse. It will be easy. Just prepare, just take this such kind of piece of paper in your hand and just try to do it like this. Okay, so this is the homework for you. So we have seen this. Next is a group of quaternions. So now let us look at this example once again. If you have taken g to be equal to r star means set of all real numbers except 0. So this do not forms a group with respect to addition. Yeah, पण ऍडिशन हेच फक्त एक ऑपरेशन नाही. आपल्याला माहिती बघा, वेगवेगळ्या बेरीज क्रिया असतात, बेरीज असते, वजाबाकी असते, गुणाकार असतो, भागाकार असतो. सो व्हॉट विल आय डू? Addition is not working, so we'll try to find out whether something else is working. My g is fixed. I will take my g to be equal to what? R star. So let's see what I'm doing. I'll do it like this. Yeah, I will take g to be equal to R star, and star I will take to be equal to dot. Dot means what? Ordinary multiplication of real numbers. What is this? Ordinary multiplication of reals. Okay, so what is your guess? You can just see what is the problem over here. Yeah, so now see, closureness is not the issue. Why? If you take any two non-zero real numbers, again their product is going to land up in a R star. Okay, associative will not be again an issue. Okay, then what is the identity? E in this group will be equal to 1. Why this is so? Since a dot 1 is equal to a for all a belongs to R star. But now, and the next important property is what? Existence of inverse. So I know that for any a non-zero in R, or I will just say instead of this, for any a in R star, I should say like this. I know that 1 by a is well defined. 1 by a also land up in R star, such that a into 1 by a is equal to 1, but 1 is what? Multiplicative identity in this group. So all the 4 properties that I have listed upstairs have been satisfied. So R star used to form a group with respect to such kind of ordinary multiplication. So I hope that this thing is also clear to you. Okay, so now let me just go to next. I think this is the 6th example for me. Okay, again you can just see that if you can take its one sort of subset. So R star, so now I know that set of rationals are also sitting inside this R star. So I will take one subset of R star, or I will just take another subgroup. Another set is like this. I will take G is equal to Q plus. What is the meaning of Q plus? Q plus means what? I will denote it as set of all positive rationals. Set of all positive rationals. Set of all positive rationals. So this will also form a group with respect to ordinary multiplication. What is my star? Star is dot. Dot means what? Ordinary multiplication. Ordinary multiplication. So similar kind of things that I did in a example number 5 that will work over here. Okay, so let me just take two more examples in this respect. So let me just denote by, let's say, M2R. What am I? M2R. M stands for matrix. M stands for matrix. This 2 means 2 by 2. So it is a collection of all 2 by 2 matrices. What is this? It is a collection of all 2 by 2 matrices. Collection of all 2 by 2 matrices with entries from R. With entries from R. So how will it look like? It will look like this. Yeah, I will just take A, B, C, D such that A, B, C, and D belongs to R. Okay, so I collected all such matrices. Yeah, I have collected all such matrices, and what I'm going to do, I'm going to define star to be equal to what? Usual addition of matrices. Usual addition of matrices. आपण 11वीला matrices शिकलो बघा. ओके, त्याचं नेहमीप्रमाणची नेहमी कळू त्या पद्धतीची बेरीज. म्हणजे फॉर एक्झाम्पल व्हॉट? So what is the usual addition? So A, B, C, D. Then I will take another matrix E, F, G, H. Then how will I define it? I will define it like this: A plus E, B plus F, C plus G, and D plus H. And I can see that this object again lands up in what? M2R. Okay, why is this so? Because see, what is here? A plus E. Here is what? It is A plus C. What is A? A is a real number. E is again a real number. I know that set of real numbers is a closed under addition. So A plus E is again going to form a real number. Similar is the case with B plus F, C plus G, D plus H. So this object is going to land up in M2R. So what will I say? M2R is closed under usual addition of matrices. Okay. So it's easy to check what are the, so matrix addition is associative. What is the next thing? I need to find out E. I need to find out E. What is the meaning of E? E means what is the identity in this group. What is the identity? Yes, you can just guess it. Identity is very, very easy. What is the identity? It will be 0, 0, 0, 0. And if I take, suppose, let's say matrix is like this: A, B, C, D. What is the inverse? Inverse will be just minus A. What I mean by minus A? It will be minus A, minus B, minus C, minus D. And this will be again land up in M2R. Why it will land up in M2R? It will land up in M2R in what sense? That A plus minus A is equal to 0. In that sense, it is going to land up. Okay. So I hope this is also clear to you. Okay. So now let's see. We will play with this example once again. Yeah. So see, there are in this up to this 7. Some are examples, some are non-examples. For example, we have just seen here that this is a non-example of a group with respect to addition. But the similar fellow has become a group with respect to multiplication, with respect to ordinary multiplication. So I will proceed further via one more example like this. Yeah, I will define one more object whose name is GL2R, because as soon as we see a matrix, one object used to come in your mind. What is that object? Determinant of a matrix. Okay. In that sense, I'm going to define GL2R. GL2R means general linear group. It is called as general linear group. Okay. What is this actually? It is collection of all those matrices A, B, C, D from M to R such that AD minus BC is not equal to 0. Yeah. What is AD minus BC? What does AD minus BC has to do with this matrix? See, AD minus BC is nothing but the determinant of this matrix. समजते हा मॅट्रिक्स चा डिटर्मिनंट झाला AD minus BC. म्हणजे सर्व असे मॅट्रिसेस M2R मधले की ज्यांचा डिटर्मिनंट नॉन झिरो आहे. म्हणजेच काय? That means what? I'll just say it is a collection of all real invertible matrices. Collection of all real invertible matrices. What I mean by real? Real means, of course, I will just say that entries in a matrix, they will be set of real numbers. Okay. So you know that how to multiply the matrix. So this will form a group. This will form a group with respect to usual multiplication of matrices. You know that how to multiply two matrices. So what is the operation? So I'll just say A, B, C, D. Suppose star is operation. So I'll just say E, F, G, H. What is this? Usual multiplication of matrix. Usual multiplication of matrices. How does usual multiplication look like? You know it, yeah. So how can I multiply it? I will just AE plus BG, then AF plus BH, then CE plus DG, CF plus DH. Usual म्हणजे नेहमी प्रमाणे करतो त्या पद्धतीचं multiplication. So you can just check all four properties of having a group. So what is the first property? That closureness. So I can just check that if determinant of this matrix is non-zero, determinant of this matrix is non-zero, then determinant of this matrix is also non-zero. This is very easy. Or you can just do it like this. How? So you just call this matrix as A, call this matrix as B. So what does A star B will become? A star will be just become A dot B. And now just check determinant of this. We know that determinant of A into B is same as determinant of A into determinant of B. But since A and B, where we are taken A and B from where? A and B from here. So they are invertible matrices. The determinant will not be equal to 0. Okay, their determinant is not equal. So this fellow is non-zero and this fellow is non-zero real number. So ultimately, their product will also be a non-zero real number. So what will I say? The product of two invertible matrices is again an invertible matrix. So indeed, this product is going to land up in a GL2R. Okay, so I will just say that. Therefore, this fellow will land up in what? GL2R. Okay, so closureness is there. Again, from rudimentary results from matrices, we know that matrix multiplication is always associative. So again, I don't need to check it like check it that. So what is the next thing? Existence of identity. So what will be the identity? So tell me which kind of matrix will be there. So that means what I want. मला असा मॅट्रिक्स पाहिजे बघा, त्या मॅट्रिक्सने कुठल्याही मॅट्रिक्स मी गुणलं तर मला उत्तर तोच मॅट्रिक्स मिळाला पाहिजे. फॉर एक्झाम्पल, आय हॅव टेकन अ मॅट्रिक्स लाईक दिस, या आय एम टू मल्टिप्लाय बाय समथिंग सो दॅट I should get it to be what? A, B, C, D. What is the condition? That this should be again land up in GL2R. That means what? हा जो काही आपण मॅट्रिक्स घेणार आहोत तो मॅट्रिक्स पण कसा पाहिजे? इन्व्हर्टिबल पाहिजे. So answer is very easy. So what is that? This will be 1 0 0 1. So this will be a identity matrix. Yeah, this thing is also known to you, known to us. So therefore, this matrix will play the role of identity in this GL2R. Okay, this matrix used to play the role of identity in this GL2R. So what is the next thing? Next thing is to find out the inverse. What is the meaning of this? That means if I take a matrix like this, if ABCD belongs to GL2R, then find a matrix, say EFGH in GL2R such that what? Product of these two matrices must be identities, such that ABCD into EFGH must be equal to I2. I2 means 2 by 2 identity matrix. Am I right? Yeah, it is as if like you know, if I call it to be A, then this will be A inverse is equal to I. But from 11th standard mathematics, I know how to compute the inverse of a matrix. If this is my A, what will be A inverse? A inverse is pretty easy to determine in the 2 by 2 case. What is that? 1 upon determinant of A. What is determinant of this matrix? AD minus BC. So this will be 1 upon AD minus BC. Then change the diagonal elements. Attach negative sign to non-diagonal elements. So this will become minus B minus C. So this will be the inverse. And you can just check that this will again land up in GL2R. This will again land up in GL2R. Why this is so? Again, what you need to check? You need to just check one condition, that determinant of A inverse is also not equal to 0. Okay, which is quite easy to do. Okay, so I hope you got it. I will just take one more, or let's say one special case of this example, because these are the quite important tools in a group theory. Okay, this is the 7th example. So the 8th example, what will I do? What is this? It is a collection of all 2 by 2 matrices such that determinant is not equal to 0. So instead of determinant is not equal to 0, that means what? Determinant is any non-zero real number. So instead of taking it to be any non-zero real number, if I take it to be equal to 1, if I take it to be equal to 1, then I will get one new kind of group, What is that new kind of group? Let me just list it down over here. So this is SL2R. SL2R is called as a spatial linear group. It is called as spatial linear group. What is this? It is a collection of all those A in GL2R such that determinant of A is equal to 1. So what I'm doing, I'm just doing a little bit jugglery or little bit modification in this example. यातले जे काही matrices बघा त्यांचा determinant non-zero आहे. ओके, non-zero real number आहे. तर non-zero real number कुठलाही न घेता फक्त मी तो काय घेणार आहे 1 घेणार. If I take it to be equal to 1, I will get another kind of group whose name is spatial linear group. Okay, and you can just see that this is actually a subset of GL2R. Are you getting subset? How to show that A is subset of B? You know that A is subset of B means what? No matter which element I take it from here, if I'm able to show that it is in B, then I'll say that A is subset of B. A is subset of B. You can just check. So GL2R consists of all those matrices whose determinant is not equal to 0. And I'm just taking one particular kind of matrices. Which kind of matrix I've chosen from there? I have just chosen those matrices whose determinant is equal to 1. I know that in a set of real numbers, 1 is also not equal to 0. So this is a subset of this. Yeah, but in fact, we can just check that this is not only a subset, but this is also have a group structure. This also have a group structure. That's why we have one more kind of definition called as a subgroup of a group. So what is the meaning of subgroup of a group? Just like, you know, set, you might have heard or you have seen such kind of Venn diagram. Suppose this is my universal set and suppose this is A. Then you can just say that A is subset of U. So here U are the set and A is also a set. Am I right? All the members of A are present inside U. So what is the meaning of subgroup of a group? It's pretty easy. If G star, so I will just say like this. I'll just say like this. Let G star be a group. Let G star be a group. Then a non-empty subset. Then you have to take a non-empty subset. Then a non-empty subset H of G is called as subgroup of G. It's called as subgroup of G if H itself is a group. If H itself is a group, with respect to same binary operation, as that of on G. So let me just tell you in a simpler language. See, G was a group with respect to binary operation star. Okay, just take a non-empty subset of G. If it again forms a group with respect to same operation means what? Star. Then that object is called as what? Subgroup of a group. Then that object is called as subgroup of a group. So what is happening? Somebody's okay. So fine. So how this is coming? I'm not so okay. Let it be. So now let's see. Here we will identify which groups are subgroups of each other. Okay. Yeah. So let's see. Or instead of this, I can do it over here also. Okay. So see, for example, see, you can just take G to be equal to R plus. Yeah, we know that set of all real numbers is to form a group with respect to addition. Then I can take H to be is equal to what? Z plus. Can I take? Yes. Why? Because Z is a non-empty subset of R, and you can just check that. Or we have also seen that Z is to form a group on its own. So Z is called as a subgroup of R. And what is the notation? Notation is like this. We can denote it like this. Z is subgroup of R. So what is the notation here? Notation is like this. Notation. Whenever H is subgroup of G, we can write it like what? H is subgroup of, like that. Okay. This is the first example. What is the second example? Second example, we can just see that whatever we have seen, SL2R is a subgroup of what? GL2R. Okay, SL2R is a subgroup of GL2R. That thing we also seen. Okay, so I think these two examples are sufficient. Now we are going to see one peculiar kind of example, which at the first look it do not looks to be a group, but it is a group. It is a group. So what is the example? Example like this. Yeah, let G is equal to A. Okay, so I have taken a collection. A is non-zero and A belongs to R. A is non-zero and A belongs to R. Okay. Then what I want to show, then I will check that, or I'm going to ask you, show that G is a group. G is a group under matrix multiplication. Under matrix multiplication. So which kind of matrix multiplication? Usual matrix multiplication. Okay, so now see, you can just compare this example that are written over here with that of GL2R. Okay, in GL2R, what is here GL? See, remember, don't confuse GL2R with this. What is GL2R? GL2R means collection of all invertible matrices, collection of all real invertible matrices. So if you look at over here, if you look at over here, so don't go towards the determinant. You can just see, if you take a determinant, it will be A square minus A square. Yeah, A square minus that will be equal to G. Don't look it in that sense. Yeah, what it says, we also, because see, operation defined there is something like this. See, for example, what is here? How to multiply A? If I take it like this, first matrix, second matrix is like this, BB. If I do this multiplication, what will I get? I will get it to be 2AB, 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 2AB. You can just see that this element is same as this element is same as this element, and you can see that what we assume that A is non-zero and B is non-zero. Since A is non-zero, B is non-zero, and 2 is non-zero, 2AB will also be non-zero. Yeah, each of the object is non-zero, therefore this will land up in G. Then this will land up in G. Okay, so this is closed under multiplication. Of course, you can check about associativity. So what is the important thing in this example is to finding out the inverse and finding out the identity. Yeah, can anybody guess what is the identity in this group? Anybody guess? So I'll just, since only 5 minutes are remaining, I'll just ask you what is the identity, and what is the, if my A is like this, if my A is like this, then what is A inverse will be equal to? Okay, so Chavan sir, shall I stop or shall I continue? Chavan sir. Chavan sir. Deshmukh sir. Or students, do if you have any difficulty, feel free to ask me, because this organizer has given me a time of 1 hour, and out of which last 5 minutes should be devoted to interaction session. Chavan sir.
हाँ sir, hello.
So shall I stop or shall I continue?
Hello.
Because, sir, shall I stop or shall I continue, or shall I open the session for interaction? What is your suggestion? Sir.
हाँ sir.
इंटरॅक्शन साठी सेशन ठेवायचा की कंटिन्यू करायचं?
आता 4 मिनिटच बाकी आहेत आपल्याकडे.
दॅट्स व्हाय आय एम आस्किंग.
बघा ना सर, कोणाला क्वेश्चन्स असतील तर काही विद्यार्थ्यांना.
इफ एनी स्टुडंट हॅव एनी डिफिकल्टी, फील फ्री टू आस्क मी. feel free to ask me. I'm going to share this, whatever I written over here, with the Chavan sir. He will share with you. But till that moment, if you have any difficulty, feel free to ask me, because last 4 minutes are remaining. So this is the exercise for you. You can do it at home. Just take a piece of paper and do the experiment that I did. So this will give a motivation. हे example तुम्ही केलं, तुम्हाला एक आत्मविश्वास मिळेल बघा की आपण ग्रुप मध्ये आयडेंटिटी कशी फाइंड आउट करायची. म्हणजे ग्रुप म्हणजे असं काही वेगळा असं काही ऑब्जेक्ट नाहीये. This is, we can create a group out of these symmetries. Okay, even you can play with the group of symmetries of triangle. You have taken a piece of paper, you can take a equilateral triangle also. Okay, yeah. Any difficulty? Chavan sir, participants, so there is a chat box. Participants are saying that please unmute the participant to ask the questions. Chavan sir. Hello. Yeah. So anybody have any difficulty? Just raise the hand, those who have difficulty. I will try from my end whether I can unmute yourself. Okay, Mukavar. Deshmukh sir, Dr. Rahul Deshmukh sir. Deshmukh sir. Chavan sir.
बोला सर.
Some participants have difficulty. By looking at the chat box, please try to unmute them so that they can interact with me.
Okay, sir. Just a minute.
Hello.
Yes.
हॅलो
Yes.
सर, स्टुडंट्सला काही डिफिकल्टीज आहेत आय थिंक, पण त्यांना अनम्यूट करावं लागेल.
मी तेच म्हणतोय.
सर मी देशमुख सरांना फोन लावू का?
हा सर, म्हणजे मुलं म्हणत आहेत ना, चॅट बॉक्स मध्ये टाकलंय मुलांनी.
ठीक आहे, ओके.
सर मुलं कंप्लीट करा म्हणतात एक्झाम्पल हे.
ठीक आहे. till that moment I will complete it, no issue.
हा सर कंप्लीट करा, काय अडचण नाही.
ठीक आहे. So what is the first thing? First thing I want to find out identity. How does identity should look like? Tell me. बघा ग्रुप मध्ये एलिमेंट कसे आहेत बघा, इथे सर्वांनी लक्ष द्या बघा पुन्हा एकदा. So elements in the group are looking like this. What? A. That means whatever 4 members are there in this matrix, all of them are same. So how does identity will look like? Identity will look, so let me just erase it. What is my job? My job is to find out the identity. So identity should look like this. I will just say, I will just call it as, let's say, instead of this, I will use another notation. Let me just see. I will call identity to be capital E. I will call it to be E. So I am taking it from G. So what should be the property? Property should be like this. A into E should be equal to A. What is my A? My A will be A. What is my E? It will be like this. And I should get it back like this. What? A. And remember, since I'm taking it from G, since I'm taking from this object from G, small e is a non-zero real number. Why this is so? You can just see what is the condition, that A is non-zero and A belongs to R. That's why this small e is non-zero real number, small a is also non-zero real number. Now it's easy to multiply over here on the left hand side. What will I get? I will get 2AE, I will get 2AE, I will get it to be 2AE, I will get to be 2AE, and this will be equal to A. Now I know that two matrices are same if and only corresponding entries are same. So, but I know that each of the entries is same. So what will I get? 2AE is equal to A. Yeah, but since A is a non-zero real number, we can cancel it out from both the sides. So what will I get? E is equal to what? 1 by 2. E equal to what? 1 by 2. So how does my identity will look like? My identity will look like, therefore, E is equal to what? 1 by 2, 1 by 2, 1 by 2, 1 by 2. And so see, this is a very important question. Most of the time, this question used to come in a JAM examination, which is a examination for taking admission to MSc. Even in the CSR, NET, STATE, and GATE, this example used to come, and we always used to get confused with GL2R. Don't confuse it with GL2R. Look at what kind of operation is given at there, what are the conditions given at there. Now, what is the remaining? Remaining to see what is the inverse. Yeah. So, can you just guess if your A is like this? If your A is, let's say A, it belongs to G. So, of course, whenever A is there, so A is non-zero and A is a real number. Then what I want to find out? Then I want to find out A inverse is equal to. What is the property of A inverse? Property of A inverse is like this. A into A inverse should be equal to what? Identity. So can you just guess by just looking at there what will be A inverse? What will be A inverse? Yes, anybody? Yes. So I guess it will be 1 upon 2A, 1 upon 2A, 1 upon 2A, 1 upon 2A. But again, check it. It will be pretty easy. How to do it? See, from this example, you can just see if your A is like this, A. You can assume that A inverse is, let's say, B. You know, again, what is the identity? Identity is 1 by 2, 1 by 2, 1 by 2, 1 by 2. Yes. From here, what can I do? You can do it like this. What? The multiplication will be 2AB. This will be 2AB. This will be 2AB. This will be 2AB. And this will be equal to 1 by 2, 1 by 2, 1 by 2, 1 by 2. Okay. So I hope I'm doing it correctly. Yeah. So this is possible if and only what 2AB is equal to 1 by 2. So I want to find out the value of B. So this will be equal to 1 upon 4A. Sorry. So this should be 1 upon 4A, 1 upon 4A, 1 upon 4A. And this 1 upon 4 is well defined. Why it is well defined? Because A is a non-zero real number. Yeah. So what is the inverse? Inverse is 1 upon 4A, 1 upon so such kind of matrix. And you can just see that this matrix land up in a given G. Yeah. This matrix lands up in a given. So this completes this last example. Okay. So Chavan sir, over to you.
Hello, sir.
Yes, sir. Yes, sir.
Hello.
Yes.
सर E equal to 1/2 लिहिले. E equal to 1 upon 2A पाहिजे ना इथं.
कुठे
हे आताच E ची व्हॅल्यू नाही का काढलेली?
Where here?
ऊपर वरती
कुठे
इथं.
हां.
1 upon 2A पाहिजे ना?
A will get cancelled. A and A will get cancelled. A is a non-zero real number. A will get cancelled. Are you getting?
Thank you, sir.
Yeah. Okay. Yes. Yeah, I will share the PDF. Some participants saying the PDF. I will share the PDF. No issue. अजून काही प्रश्न आहे का कोणाचे?
कोणाला प्रश्न विचारायचे का? अजून विचारू शकता का? सर आय थिंक स्टुडंट्सचे क्वेश्चन संपलेले आहेत. चव्हाण सर, दारकुंडे सर, आय थिंक स्टुडंट्सचे क्वेश्चन संपलेत, सो मी कंक्लूड करते सेशन.
Yes madam, no issue.
So first of all, I am very much thankful to Dr. Nitin Darkunde sir for his as usual.
Hello madam. Madam.
Yes sir.
मी मानतो आभार त्यांचे.
ओके सर, चालतंय. जस्ट मी 1-2 लाईन बोलते सर, एकच सेकंड.
चालतंय.
ऍज युजल आता मी मराठीत बोलेल मग. ऍज युजल जे आहे ते दारकुंडे सरांचं लेक्चर आम्ही बऱ्याच वेळेला अटेंड केलेलं आहे आणि नेहमीप्रमाणे सरांचं लेक्चर हे अतिशय चांगलं झालेलं आहे सरांचं टीचिंग हे खूप एन्थुसियास्टिक असतं आणि मोर ओव्हर सर जे आहेत ते प्रत्येक छोट्यातली छोटी गोष्ट मुलांना एक्सप्लेन करतात सो दॅट स्टुडंट्सला ते व्यवस्थित पोहोचेल याची ते खबरदारी घेतात. सो ऍज युजल सर तुमचं लेक्चर खूप छान होतं आणि मी सरांना रिक्वेस्ट करते की तुम्ही आभार प्रदर्शन करावं.
धन्यवाद मॅडम. आजचं जे काय सेशन आहे अगदी चांगल्या पद्धतीने झालेलं आहे. मी डॉक्टर होगे, कोऑर्डिनेटर ऑफ YCME सेंटर, दिगंबरराव बिंदू महाविद्यालय भोकर. आझादी का अमृत महोत्सव या निमित्ताने नॅशनल लेक्चर सिरीज आमच्या महाविद्यालयाच्या वतीनं, YCM सेंटरच्या वतीनं, महाविद्यालयाच्या ऐक्यच्या वतीनं या ठिकाणी आयोजित केलेलं आहे आणि आपल्या सर्वांना एकत्र आणण्याचं आमचे डायनामिक पर्सनॅलिटी म्हणजेच डॉक्टर चव्हाण सरांनी सर्वांना एकत्र आणलेलं आहे. आपल्या गणितासारखा हा विषय जो BSc आणि MSc मॅथ आमच्याकडे YCMच्या अंतर्गत चालतं आहे आणि रेग्युलर सुद्धा चालतं आहे, तेव्हा या सर्वांना फायदा व्हावा या उद्देशाने ही लेक्चर सिरीज आमच्या चव्हाण सरांनी या ठिकाणी परिश्रम घेऊन त्या ठिकाणी ठेवलेले आहे. तेव्हा काल मान्यवरांच्या हस्ते उद्घाटन झालं आणि आज नितीन दारकुंडे सर, डॉक्टर आपलं स्वामी रामानंद तीर्थ मराठवाडा विद्यापीठ नांदेडचे एक चांगले गणित तज्ञ म्हणता येईल किंवा एक आताच आपण मॅडमच्या वर्षा बोरगावकर मॅडमच्या माध्यमातून त्यांचा परिचय आपण ऐकला की निश्चितच सरांचं एक मॅथ मधलं एक हँड मॅथ म्हणतो आपण त्या पद्धतीचं आहे. तेव्हा त्यांनी अगदी चांगल्या पद्धतीनं, अगदी सोप्या पद्धतीनं, मी जरी मॅथचा नसलो तरी सुद्धा अगदी मला सहजरित्या ते लक्षात येत होतं. कारण मी इकॉनॉमिक्सचा आहे, इकॉनॉमिक्सच्या स्टॅटिस्टिकच्या अंतर्गत मॅट्रिक असेल, इतर कोणत्या गोष्टी असतील ते काही अंशी मला सुद्धा लक्षात येतोय. म्हणजे निश्चित आपल्या सर्व विद्यार्थ्यांना त्या या ठिकाणी लक्षात आलेले आहेत. तेव्हा आपल्या ह्या सेशनला जवळपास 120 विद्यार्थी पार्टिसिपेट झालेले होते आणि या 120 विद्यार्थ्यांमध्ये विशेष करून मी या ठिकाणी आवर्जून या ठिकाणी सांगतो आहे की डॉक्टर नितीन दारकुंडे सरांचं स्पीच किंवा एक शिकवणे किंवा हा पिरियड करण्यासाठी निश्चितच आपल्या स्वामी रामानंद तीर्थ मराठवाडा विद्यापीठाच्या अंतर्गतले जे काही अनेक कॉलेजचे सर लोक सुद्धा या ठिकाणी उपस्थित झाले होते. त्यामध्ये विशेष करून मी या ठिकाणी सांगतो आहे की ग्रामीण महाविद्यालय वसंतनगर येथून डॉक्टर झंपलवाड सर या ठिकाणी अटेंड झालेले आहेत. त्यानंतर आखडाबाळापूर कॉलेज मधून डॉक्टर सुधाकर गाडे सर या ठिकाणी उपस्थित झालेले होते. त्यानंतर डॉक्टर लांब सर किनोटून या ठिकाणी अटेंड झालेले होते. तेव्हा यांचे मी या ठिकाणी आभार मानतोय आमच्या अभ्यास केंद्राच्या वतीनं, आमच्या महाविद्यालयाच्या वतीनं आणि आमच्या महाविद्यालयाच्या गणित विभागाच्या वतीनं. या सेशनला जवळपास भोकर, हदगाव, दिग्रस, मंठा, परभणी, गंगाखेड, वसमत, नायगाव, माहूर, लातूर अशा अनेक महाविद्यालयातून अनेक महाविद्यालयात चालणाऱ्या BSc आणि MSc सेंटरच्या अंतर्गत हे सर्व विद्यार्थी या ठिकाणी उपस्थित झालेले आहेत. तेव्हा या सर्वांचा सुद्धा मी या ठिकाणी आभार मानतो आहे. आणि त्याचबरोबर आजच्या या सेशनच्या चेअरपर्सन सायन्स महाविद्यालयाच्या गणित विभाग प्रमुख डॉक्टर वर्षा बोरगावकर मॅडम यांनी सुद्धा चांगल्या पद्धतीने हँडल केलं. त्याबद्दल मी ऐकवाक YCM सेंटर आणि गणित विभाग दिगंबरराव बिंदू महाविद्यालयाच्या वतीने या ठिकाणी खूप खूप आभार मानतो आहे. आणि परत एकदा या पार्टिसिपेट सर्वांचे आभार मानतो आहे. आणि रिसोर्स पर्सन डॉक्टर नितीन दारकुंडे सरांचं परत एकदा आभार मानून या ठिकाणी आपण थांबूया. धन्यवाद. आणि विशेष करून आपण या ठिकाणी सर्व विद्यार्थ्यांना मी या ठिकाणी अशी विनंती करतो आहे की उद्याचं सेशन सुद्धा बरोबर याच वेळेला दिलेल्या टाइम टेबल नुसारच सुरू होईल. सर्वांनी हे 7 दिवस चालणाऱ्या सेशनचा आपण फायदा घ्यायचा आहे आणि त्याचबरोबर सर्वांनी जॉईन व्हायचं आहे. जे इतर विद्यार्थी असतील त्यांना सुद्धा लाभ मिळण्यासाठी आपण जॉईन करण्यासाठी त्यांना लिंक पाठवायची आहे. धन्यवाद.
थँक्यू सर. थँक्यू दारकुंडे सर. थँक्यू
थँक्यू थँक्यू थँक्यू टू ऑल.
थँक्यू सर. थँक्यू सर.
थँक्यू.
दारकुंडे सर,
हा मॅडम.
तुमचा जो बायोडेटा अवेलेबल होता वेबसाईट वर तो घेतला बरं का?
हो तोच आहे
म्हणजे
मॅडम.
तो अपडेटेड होता नाही होता मला नाही माहिती.
दारकुंडे सर.
हा सर. ओके सर. नमस्कार.
नमस्कार सर.
काय म्हणतात?
विशेष म्हणजे आमचा चिरंजीव
हो, आठवतंय
आमचा
आपली भेट झाली
चिरंजीव
पूर्वी.
तुम्ही इथं आले हा आमचा चिरंजीवला ते ची परीक्षा देण्यासाठी तुमच्याकडे हे झालेला होता.
हो, आठवतंय. मॅडम आल्या होत्या, तुम्ही आले होते.
Hello, sir.
हा सर.
Nice presentation, sir.
हा
थँक्यू.
Gade sir speaking.
Yes, sir.
नमस्कार गाडे सर.
Okay, madam. अगदी